Hello friends and welcome to ISIFE EDUBLOG once again, and today we'll be looking at geometric progression, commonly known as GP. So what is this geometric progression? Now we can define a geometric progression to be a type of sequence whereby each succeeding term is gotten by multiplying each preceding term by a common number. Okay? So what do we mean by that? Now I believe that we all can still remember what we mean by a sequence. Okay, now we said that a sequence is a group of numbers, a set of numbers that follow a particular pattern or rule, right? So if you have a set of numbers, a group of numbers, that the pattern or the rule that they follow is multiplicative, now we refer to such set of numbers as a geometric progression. Now, for example, if I have this group of numbers 2, 4, 8, 16, 32, 64, and so on and so forth. Now, by carefully observing this set of numbers or this group of numbers, you find out that they follow a particular pattern, right? And so this is a sequence because of the pattern they follow. Now, but what pattern does it follow? You find out that this is my succeeding number, this is my preceding number. Now, for every succeeding number, you need to multiply its preceding number by 2. So this is 2, right? If I should multiply this 2 by 2, it will give me 4. If I should multiply this 4 by 2, I'll get 8. If I should multiply this 8 by 2, I'll get 16. If I should multiply this 16 by 2, I'll get 32. And if I should multiply this 32 by 2, I'll get 64. So this tells us that if I want to get the succeeding number after 64, I'll need to multiply 64 by 2, right? And so on and so forth. So this set of numbers that follow this kind of pattern or this kind of order is known as geometric progression. Right? Now, another good example is something like, let's say 3. 3, 1, 1 over 3, 1 over 9, 1 over 27, so on and so forth. Now, if you look at this group of numbers or this set of numbers, you find out that they are following or they are obeying a particular order. So it is a sequence, right? But what order, what pattern are they obeying or observing? We found out that if I should multiply this, my first term, by 1 over 3, I'll get 1. If I should multiply 1 by 1 over 3, I'll get 1 over 3. If I should multiply 1 over 3 by 1 over 3, I'll get 1 over 9. And if I should multiply 1 over 9 by 1 over 3, I will get 1 over 27. So this group of numbers obey a multiplicative kind of order or pattern, or they follow a multiplicative kind of pattern. So this makes it a geometric progression. Alright? Now, for every geometric progression, the first number, now like for example for this, now this is the first term of this very particular progression. So the first number is the first term, the second number is the second term, the third number is the third term, the fourth number is the fourth term, the fifth number is the fifth term, the sixth number is the sixth term, and so on and so forth. Now the same is applicable here. My first number is known as our first term, the second number is known as our second term, the third number is known as our third term, the fourth number is known as our fourth term, the fifth is known as our fifth term, the sixth is known as our sixth term, and so on and so forth. Now, but remember, for every geometric progression, it has to be multiplied by a particular number, right? Like this one, this very particular geometric progression was gotten by multiplying every preceding number by what? By 2. The same as this one, every succeeding number was gotten by multiplying every preceding number by 1 over 3. Now, this common term or this common number that is used during in a particular geometric progression is known as its common ratio. This particular number that is used in every geometric progression is known as the common ratio. So that number that was used to multiply every preceding number here is known as its common ratio. While every number that was used to multiply every preceding number here is known as its common ratio. So for this, we have our common ratio to be 2. And for this, we have our common ratio R to be equal to 1 over 3. Alright? So now let's look at the general terms that we can find under geometric progression.